I'm doing my first problem as number 2. So to start off, I know I need to factor both the numerator and the denominator. So for the numerator, we're left with x times x squared minus 9. And then for the denominator, we are left with 4 x plus 2, and then x minus 1. So now in order to find our zeros, we know that our zeros are always in the denominator. In the numerator. So we're going to do zeros. Okay, I know I'm going to have a 0. I know I'm going to have one at -3, another one at 0, and another one at 3. So we need to write these in x-intercept form. So there was one at -3, 0, another one at 0, 0, and then last one at 3, 0. Now we're going to find our vertical asymptote. And our vertical asymptote is our x. And clearly we can see that we're going to have 2 vertical asymptotes because we're setting it equal to 0 for both. So we are going to be left with an x at -2 and then an x at +1. Now to find our horizontal asymptote, we can see that the degree in the numerator is higher than the degree in the denominator, so there is going to be none. So now let's find our domain. In order to find our domain, we just have to make a quick sketch of what the graph is. So let's put down what we know. We know that there's a point at -3. Okay, we know that there's another one at the origin, and then another one at 3. And this is also a point. And then we know we have vertical asymptotes at -2. So we're going to mark that around there. And this is at x equals -2. And then we have another one at +1. And that's x equals 1. So now when we put it into a calculator, which I've already done, and we graph it, we can see that our graph is supposed to look something like that. So our first point is going to go through the through the -3. And then it's going to go around here, up that way. And for the center, it's going to go like this, never crossing the asymptote lines. Okay, and now we can see what the domain is from the graph. And the domain we see, it starts at -infinity, ends at -2, picks back up again at -2, ends at the 1, picks back up again at 1, and continues to infinity. And that is it. For my next problem, we're going to be doing number 3. So we can clearly see that you don't need to factor the numerator or the denominator. So we're just going to get right into it and start by finding our zeros. And like always, our zeros, we can find it by setting the numerator equal to 0, leaving us with a +2. And now to find our vertical asymptote, we do this by setting the denominator equal to 0. So let's solve this equation really quick. -6 equals 0. So we're going to add 6 to the right side, leaving us with 2x equals 6. We're going to divide both sides by 2, leaving us with x equals 3. So our vertical asymptote is at x equals 3. And now for a horizontal asymptote, we can see that the numerator and the denominator both have equal degrees. So that means we're going to it's going to be 1/2 because you want to take whatever the leading coefficients were. And now to find our denominator, we need to do a quick sketch of what the graph would look like. So we know that we have a 0 at 2. And we know our vertical asymptote and our horizontal asymptote. So we know we have one at 3. So that's somewhere around here. And that's x equals 3. And we have our horizontal asymptote at y equals 1/2. And we're just going to put that one just around there. So y equals 1/2. And now, oh, I almost forgot. We need to write this as a point since it is our coordinate. And then when we put it into a calculator to figure out how it's going to be graphed, we see that it goes through the 2 and up that way. So we're going to like this. And it doesn't, even though it looks like it doesn't cross that horizontal asymptote line. So we're just going to put it right beneath it like that. And now we can see what our domain will be. So we see that our domain starts at -infinity, ends at 3, picks back up again at 3, and then ends at infinity. For my last problem, I'm going to be doing number 5. So to start off, I know that I need to factor both the numerator and the denominator. So let's do that really quickly. So the numerator comes out to be x times x plus 1 and x minus 4. And the denominator is going to be 4 times x minus 3, x plus 3. Okay, now that we have this, let's figure out what our zeros are. So we know that our zeros always come from the numerator, so we're going to set this equal to 0. So our zeros, as we can see, we're going to get -1, 0, 0, 0, and finally 4, 0. And now let's figure out what our vertical asymptote is. So we have, in order to do that, we have to set the denominator equal to 0. And we see that that's going to leave us with x equals to 3 and x equals to -3. Now for our horizontal asymptote, if we look at the degrees, we see that because the numerator's degree is bigger than the denominator's degree, we're not going to have one. So we just put none. Now we need to find our domain, but in order to find our domain, we have to sketch it. So let's just draw a rough sketch of what it would look like. So we know that we have a point at -1, so we'll put that around here. We'll see -1. We have another one at the origin, so, and then finally we have one at 4. And we know that we have a vertical asymptote at 3 and -3. So here we'll put this one here at 3. And this one is x equals 3. And then we have another one at -3. So we'll just put this one around here. And this one is x equals -3. Now that we have this, we are going to plot it into a calculator so we can get what our graph will look like. And I've already gone ahead and done that, so now we just graph it, and our graph should look something like this. So it doesn't pass the vertical asymptote line, and just around there. And then it goes through these 2 points here and up like that. Yeah. And then lastly, we have one right here. And it should be something like that. So now to figure out the domain, we're looking at the graph. We can see that it starts at negative infinity. It ends at the asymptote, which is -3. Then it starts back up again at -3, ending at 3. And then one last time it starts back up again, 3 to infinity. And that's it.